Welcome everyone to this latest edition of the EuCAPT video profiles, where we try to interview some leading figures in who belong to the European Consortium for Astroparticle Theory to try and understand a little more about what work they do, what interests them in their research, but also perhaps what makes them tick. My name is Bradley Kavanagh. I'm a postdoctoral researcher at the Instituto de Física de Cantabria in northern Spain. And it's a great pleasure to have Gabrijela Zaharijas here with us, an assistant professor in the Center for Astrophysics and Cosmology at the University of Nova Gorica in Slovenia. Hi, Gabi.
Hi, Bradley. Thanks for inviting me.
No, it's a great pleasure to have you. So I could give perhaps a long introduction to you, but I think it makes sense to just jump in with some questions and we can hear straight from you. So maybe first off, you can tell us where you're from and how you became interested in science.
Good, yes. So I am actually from Serbia originally. And so in fact in Serbia we have actually one great institution which is called Petnica. It's basically a little sort of year-long camp for extracurricular activities for high school students. Okay. So it was lots of fun because we could, go there, a few times a year and discuss science and sort of figure out what we like in science. Actually, they also have humanities, architecture, psychology. So you just
Yeah.
apply for some field that you think you like, and then you do some like mock projects. And
Okay.
so I did this in my high school already. And so somehow was lucky to meet some great physicists there and actually, fall in love with the field. And
Yeah.
yeah, it was
Was
sort of.
it anything specific about physics? Was it just that you met people who were, inspirational in the field of physics, or?
Yeah, I think it's a combination of the two, of both. Because of course, I think as many physicists, I always love the simplicity, in physics and like sort of symmetries,
Yeah.
particles. I mean, this thing how you can explain many things by a few rules. So that was already appealing. And then of course, if you meet charismatic people that can actually tell you what science is about, because sometimes in high school, physics seems it's hard to see actually the essence of it, maybe, depending on the teacher you have.
Yeah.
So having seen real scientists and doing some mock research work also helps.
Yeah. Physics can be very simple and beautiful in that way, but you first need someone to show you that simplicity and
Exactly.
beauty. Yeah.
Mm.
Okay, so this got you interested in physics. Could you tell us how your career progressed? Where did you study, and then what your current situation is?
Yeah. So after Belgrade, I did a PhD at NYU, New York University, and then I started having like two body physics situation. So that meant that we sort of converged quite a bit. I mean, moved a bit before converging, let's say
Yeah.
this way. So I was after NYU. I was in Chicago area in Fermilab and Argonne National Labs. Then I moved to Stockholm to newly founded OKC Center at that time. And then we were together in Paris, in Saclay, then Trieste. And so where I was a postdoc first at ICTP, and now I still live in Trieste, but I work in Slovenia, as you said, permanently.
Okay.
So a long windly path, but yeah,
It,
it worked.
I mean, I think a lot of physicists will, understand this kind of trajectory that takes you all over the place. It's
For
certainly
good and
not.
bad, in a sense. Yeah, exactly.
Yeah, it has good aspects and bad aspects, certainly. Maybe you can tell me, kind of what your research focus is, what are you most interested in and perhaps how that's evolved over time through this winding path of jobs and
Exactly. Thank you. So right. So this is also. So I started during PhD. I did more particle phenomenology, but focusing on dark matter already, of course, and dark matter searches, but very widely, like direct detection, indirect, but in stars and like in various targets. Then in Chicago, I started working with Dan Hooper. That sort of introduced me to gamma rays. And those were also the years where Fermi-LAT satellite was about to be launched. long ago.
Yeah.
And so then after that with Fermilat, basically from then on it was gamma rays and dark matter sort of ever since, mostly.
Yeah.
Because there were with Fermi-LAT, there was lots of discoveries, dark matter and outside of dark matter, but still it was very exciting all the time. So sort of I stayed in that research area. Now I'm focused also on CTA, Cherenkov Telescope Array, that will come. And I'm quite interested to pursue also Vera Rubin and sort of lancing probes of dark matter. So this would be a bit departing for gamma rays, but I think it's also exciting probes for dark matter. So yeah, this is something I'm looking forward to.
Yeah. I mean, the field of dark matter has a lot of diversity in the sense of there are lots of different probes, and sometimes you have to venture out into a slightly different field to learn something new.
Exactly.
So you talked about the Fermi Lat telescope, and when it was about to be launched. Would you say that was the most exciting, the thing that you were most excited about during your career? Was there a really exciting moment?
So definitely, I have to say now when I look in retrospect, I mean, like old people, no, was
When you
I
reminisce, yeah.
exactly back in the days. Definitely, it was extremely exciting time. And so, of course, so before for me, LAT was launched, it was already, expected to be able to say something about dark matter.
Mm.
But then also all these other discoveries, like with Fermi bubbles, with galactic center excess. Yeah, this was all, discoveries that first made us confused, and we tried to figure them out and took a while in research. So I cannot complain. Like it was definitely not boring. Like there was always something to figure out. So I really, now going back, I think the first several years of Fermilat, that was also Pamela MSO2, those discoveries were definitely something to be, something exciting to be
Yeah.
understood. And I'm wondering with new generation satellite, I mean, observatories, if it's going to be the same. Like, is it always like this, or we'll
Yeah.
see.
I mean, it seems like with Fermilat and with these other experiments, we sort of opened a box of data and suddenly had a huge amount of new information.
Exactly.
And you see things that you were not expecting. And like you said, you're at first confused, and then you realize that in some ways it's a good confusion because you can start learning things from
Exactly.
new data.
And even the things you sort of expected, somehow, usually, of course, you're not completely right, because it's
Yeah,
always manipulation, so you have to adjust and learn new things as well. So yeah.
yeah.
Thanks.
Okay. So, what do you think the most exciting open questions in the field? What would you like to what questions would you like to answer? And do you think these new experiments, which might open a new box of data, do you think they will have a big role?
Yes, I mean definitely. I mean, I sort of expect it. I hope. I mean, of course, like I'm always, modest to surprises. But what I want to say, yes, I think definitely. Of course, the nature of dark matter is always there as a big question, and so yeah, I'm not I'm sort of equally excited because it really is a question that one feels like we should be able to say more about, even if maybe it's not finally solved, even in the near future. So yes, I think with again CTA and Vera Rubin, we should be able to say something. At least we'll definitely probe new parts of parameter space that is very motivated, and so we'll learn where nature lies on that question. Then yeah, of course with Vera Rubin and Euclid with gravitational probes, and so it's more about like small scale structure, maybe that we will learn like what are the smallest objects maybe dark matter makes. And with gamma rays, are there signals, in indirect searches in that sense, and also about accelerators. Like we learn, I hope, a lot about, I don't know, electron population in the galaxy activities and things like that. So yes, this is something I sort of am looking forward to learn more, and I
Yeah.
think we'll learn more in the next 5 years, say, to be conservative.
Yeah, there's lots to be learned certainly, and like with Fermi, we don't know until we open that box and start looking exactly what we're going to see. So hopefully we can be pleasantly surprised in the next 5 years or so. Yeah.
Exactly.
So maybe you could say something about what you like and dislike about being a scientist. We talked about, for example, traveling around and moving to different positions, and that has good sides and bad sides. I think that's a reflection of being a scientist as a whole. There are some good things and some bad things. Maybe you could say something about that.
Yes, exactly. So yeah, I'm still divided on that issue. So in a sense, like, I mean, every move, I mean, every new place where you work, it's definitely a sort of learning curve, a very steep learning curve.
Mm.
So all of these experiences, taught me a lot in on different sides. Like you build your network, you learn physics, new aspects, new views. So it's always useful. On the other hand, also this insecurity is a little bit, of course, has its own weight.
Yeah,
So
yeah,
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 so it's not a pleasant feeling while it lasts, but then sort of again, in retrospect, it's good that one has those experiences,
yeah,
those sort of, one learns a lot. Yeah, so right, so exactly. So somehow I do not know if I have something much more new to say. I mean, a little bit of this that I don't like, and it's a pity, maybe sort of losing people from academia that I saw many talented people leave, which is of course good for them and maybe good
yeah,
for
yeah,
society, but personally feels sort of a loss for science in some sense. And yeah, yeah. I mean, that's it. Also, for example, grant writing, again, it's always good and bad. It's good that there are many these schemes where one can propose their ideas, they're evaluated in a meritocratic way. So it's a positive development.
Mhm.
On the other hand, maybe it's not super efficient the way it is done at the moment.
You mean the way that many
Yeah,
people end up spending their time
yeah,
writing grants
exactly.
and
Grant,
asking for money to do
and
research rather
exactly.
than perhaps doing research.
Yes, exactly. So in a sense, like I think that some amount of time should be spent because you have
Mhm.
to formulate ideas. There should be a market of ideas. On the other hand, I often feel it could be done in a bit more efficient way so that, but yeah, this is all progress, let's say. I mean, it's not like a good or bad. It's like two sides of the
Yeah, yeah.
of the key
Do,
that needs to be improved. Mhm.
do you have any suggestions or thoughts on how the grant proposal system could be changed? This
Okay, this
perhaps a very broad question, but it seems
no,
like
no,
maybe you've
indeed. So
thought
this
about
is
this a little.
no, I thought about, but I did not crack that one. In the sense, like I understand how immense problem it is to actually organize, such endeavor of,
Yeah,
full scientific community applying for the grant. So I appreciate the challenge. So yeah, I do
yeah.
not have yet a wisdom on that one.
Acknowledging that there is a challenge sometimes is the first thing. But yeah, we're also looking for dark matter, which is quite a challenge. So let's stick maybe to
Exactly,
one
exactly,
challenge at a time.
exactly,
Okay.
correct.
So, what new skills would you like to learn in the next year or the coming years, either to prepare for upcoming discoveries or just to keep up to date with new developments?
Right. So I think here I have a rather sort of maybe trivial answer because I mean, already for several years, I got actually interested in this machine learning sort of techniques and if they can be brought up to my kind of science, like
Mm.
the things that I do and in which way. And
Yeah.
so this is, of course, like many people are, wondering about this. It's not, of course, original. But yeah, I always feel like that now. I always feel I need more time. That I would like to have more time to dig deeper into that. So I work on some of these topics with my students and postdocs, but sort of I feel I would like to, go deeper
Yeah,
and
go deeper and learn more. I mean, I often speak to people and they are looking for ways to use machine learning. And I think sometimes there could be a criticism that people have this tool and really
mm,
they don't know what to use it for and they just want to use the tool even though it may not be the best thing for the job.
exactly. So this is where I am now. Like, so I'm
Okay.
trying find out. No, no, exactly. This is also always my question, because I mean, it's clear that this is a powerful tool, but it's also clear that our questions are really niche questions, are really particular kind of questions,
Yeah.
especially in gamma rays that you have only one sky, you know, like, so that my challenge now is like, which question, I mean, to find questions to which, you know, machine learning can be a good answer. I mean, powerful answer too. And so I'm
Yeah.
still in the exploratory phase. We've been trying a couple of things and results are, I mean, it is promising, but still I feel there should be, you know, a next step where it will
Yeah.
be, you know, when we learn a bit more the methodology in the way it really can bring, you know, progress that cannot be even, you know, dreamed of otherwise. For
Yeah.
now, sort of, I feel it's comparable, you know, drink some, take some, but yeah, I think we still, at least myself, have to figure out, you know, the direction in which it can really go much
Yeah.
further.
Perhaps, you know, waiting to really unlock the full potential of machine learning to, you know, accelerate things.
Mhm.
And I guess machine learning would be most useful in a situation where, you know, just the scale and scope of the data is an obstacle, you know, and in that situation, machine learning should be really powerful, right?
Sure. No, no, exactly. So this is all sort of in preparation also for these new observatories that we discussed at the beginning. So for sure, like at some point you will not be able to do without. But on the other hand, I feel that now we should also learn how to use it in the most productive ways. So that
Yeah.
once when we cannot really do much without it, that we have these sort of directions that can bring us the farthest, sort
Yeah.
of that.
We have to do some preparation and get ourselves ready now so that when we open this big box of data, we can make the most of it and you know
Exactly.
learn as much as possible.
Exactly, to build intuitions, because in a sense in physics, sort of most of us have intuition or working along in the field, but this is a different field. So yeah, sort of we have to build intuitions and try to play with it enough now so that we are, you know, ready.
Yeah, yeah, yeah. So, are there any other obstacles? I mean, if you know the just the sheer scale of data is an obstacle in the future, do you think there are any other obstacles in the field that prevent us from, for example, discovering the nature of dark matter or you know, answering any other very fundamental questions that we want to answer?
Yeah, so for that, I don't have a feeling that there is a huge obstacle. I think as a field, we are quite ready. I mean, quite open-minded. People are considering different things. I don't think that we are dogmatic in any way. I think that we are sort of, yeah, ready to do it, and the data will be there.
No,
So it's going to be hard work.
that's really nice to hear. I mean, in the sense that, you know, if there's no big obstacle, then we're just hoping that nature is waiting just around the corner to reveal itself, and then we can learn all the things we want to learn. If we are ready, then it's just a matter of waiting and continuing to work, I guess.
Yeah. I mean, ready in a sense like that we sort of are open-minded. But then,
Yeah.
of course, it is. I mean, even if, how should I say, new physics is there, or even astrophysics will be there, there is still going to be hard work to find, as you're saying, like to find a way how to combine various models and to treat them, you know, with proper uncertainties and
Yeah.
sort of, yeah, to get physics out will be hard. But I don't see really obstacles at this moment to that.
Okay.
Hopefully.
No, that's great. I like that optimism. Yeah. Okay, so maybe to step back and think a little bit about EuCAPT itself. So um, the idea of EuCAPT was to kind of stimulate astroparticle theory and cosmology as a field in Europe, and to start connecting, you know, institutes who might not usually interact and people who might not usually interact to try and use our combined strength and openness to do good things. So, what do you see as UCAPT's role? Do you think there's something that UCAPT could be doing, or how do you see that?
No, I actually, so yeah, I mean, I actually love it. I have to say something. I'm afraid I will not be too critical because I think it was really needed. I mean, some experimental communities had these groups already. I think for this sort of theory, phenomenology, data analysis, crowd, it was really needed, such organization. And I think it's doing a good job. I mean, really, with all these meetings that you organize, with grants that you give to young people. So I think my students and postdocs benefit definitely from all of those activities. And then also for Slovenia, that is rather small country, I think having such big networks where we can all meet and be represented and have a voice, it's a great thing. I do not have yet complaints. It was really
I
good
mean,
that we started.
I think that's a good point. That this one about perhaps smaller institutions or countries which are traditionally less well connected or less visible, being able to be part of a wider network and be seen a little more, have more of a voice, but also just being able to connect with other places, I think is.
Sure, sure, sure. In organized way, in a sense, like of course scientists will always have their own networks,
Hmm.
but I think this adds a layer that sort of it's beneficial. I
Yeah.
find, yeah,
Yeah.
indeed.
Okay. So how do you like to relax after a hard day's work? So this is taking a step back away from the beautiful symmetry of physics and thinking about broader things.
Right, right, right. Okay, so yeah, but again, this is also a rather straightforward answer, like yoga. For
Yeah.
hot yoga, actually, I always recommend it to people, but not, yeah, it doesn't fall blind very, I mean,
Okay.
always. There is
Perhaps you could say what hot yoga is for those
hot.
who don't
So
know.
I love it. I love it because it's a hot room. Like it's
Okay.
sort of like sauna, but it's not usually people phase out at that point, say, I don't like sauna. It's not like that, no, because sort of it's very active. So you do yoga, you have to I mean, it allows you to stretch much more because
Okay.
it's,
Hmm.
and then also you have to stay very, very focused, because in yoga, usually they say focus on your breath, which becomes a bit hard to, get the point. But when you are in a hot room, you really have to stay focused on the breath, because if you forget to breathe, then you sort of get dizzy. It's really challenging on the body. But I mean,
Okay.
this sounds funny, but it really keeps you so focused. And that's also why it's very relaxing, because you really have to think about the breath. You cannot think about, work and other things. So it sort
Okay.
of becomes a combination between meditation and so exercise. So I really love it.
Okay. So it's an extra challenging yoga.
Exactly.
And it's sort of, you said it was like meditation almost. This is something you do to relax, to sort of clear your mind.
Yeah, exactly. I mean, both the stretching part, the physical, and then also this thing that you really have to, focus on what you're doing at that moment, because as physicists as well, I think it's natural to everyone. We always think half the brain is always thinking about about work.
Yeah.
And this kind of yoga sort of cuts that
Yeah.
a little
Yeah.
bit, because yeah, you cannot otherwise do it. So yeah, that's why I recommend it. I mean, that's why I love it actually. And then,
Yeah.
yeah.
I think a lot of physicists would probably say that they enjoy what they do and they enjoy thinking about the problems that they're working on. But sometimes you need to be able to switch off your brain a little and have some downtime. And this sounds like a good way to do that.
No, no, exactly, exactly. No, indeed, indeed. So you're completely right that I did not see this as needed. Actually, in fact, it's a natural way of being, always thinking
Okay.
about it. But I think sort of I find it beneficial, because like detaching, so then it just relaxes you and then gives you fresh perspective.
Yeah. Yeah.
Yeah,
And
that's-
sometimes that downtime for your brain can be really helpful later on when you go back to thinking about something. You can find that this thing that you've been thinking about for a long time suddenly becomes simpler, or suddenly you can approach it with a new perspective, as you say, and it helps. Yeah.
Sure.
Okay, so to finish off the interview, I'd like to ask what your advice would be to your younger self, perhaps, or to younger colleagues who are only just starting in the field.
Right. So I thought a little bit about this. Of course, it's very personal, and then of course depends to whom. I mean, I feel that. So again, this is not. This is a bit about job finding. So it's not really science, in a sense. Like two things maybe. One is that sometimes people choose to work in some field where they feel it's going to be easier to find work. That I would sort of think that one should not worry so much. At least I was like that. So for good or bad, in a sense, I think it's sort of, pursuing what you're really passionate about.
Mhm.
But then at the level of work, because I know that at least in my times, people were very afraid, maybe even, or knew very little about even switching to non-academia or thinking about what kind of work we can do as physicists.
Yeah.
And so it's putting a lot of pressure. I don't know if this is still like that. I think it's much less, given that, field became much more fluid, this academia versus non-academia. But still, I think over time, and also seeing many people that were leaving or looking for works, I sort of realized that it's actually, one can almost always or always find a job as a physicist,
Yeah, it's a
one
good.
should work maybe less, and then just, there's lots of resources, and if one gets tired of moving or whatever. And there are also many grants now that combine academia versus non-academia.
Yeah.
So I think in that sense, one should, I mean, probably young people are very aware of that, but still, I think they should maybe, just go for what they like. And when they don't like it anymore or want to change, like, not to be worried about what will happen, but because it seems it's really all, I mean, they really have the set of skills that can do a lot of things. So
Yeah. No, I think that the skill set that we are developing in physics is very valuable for a lot of fields, especially. I mean, you were talking earlier about machine learning, and a lot of people now are learning a lot of machine learning and data science, and just generally how to look at data, how to understand statistics. These are things which are becoming more and more in demand outside of
and,
academia.
and indeed, and actually are present everywhere. I mean,
Yeah, yeah, yeah.
I mean,
I mean,
needed everywhere. Just that, the people maybe did not before target physicists as the problem solvers in that sense, but we definitely have the skill set.
yeah,
As I was saying, there are some grants like that allow you to do academia, but also spend lots of time in non-academia as
mhm,
well. So this also helps people to realize what it is that they actually want.
yeah. I I think there's becoming less of a let's say stigma about leaving
That
academia as well. And as more people know people who have spent time outside of academia, and have
not
succeeded and,
happy,
and are happy, I think
right?
it's becoming less and less scary, let's say.
Right, exactly, exactly. So again, wrong that it is for as it is for science. I mean, I think it's good for people, and so
Yeah.
right, maybe just just not worry.
Okay, so your advice is to follow what you're interested in primarily, and perhaps not worry too much about your chances of getting a job, because if you gain
Eventually,
skills, then you'll always be able to find something.
that you like, exactly.
Yeah.
That's good.
Okay. I think that brings us to the end of the interview. So I'd like to thank everyone for listening, for tuning in, and I'd like to especially thank Gabby for giving us what I think is quite an optimistic view of the field. We're ready to discover things, and also we have the skills to kind of to do that, and to find work outside of academia if that's what we end up doing. So I've really enjoyed it. Thank you. It's been a very optimistic and very enjoyable chat.
Thank you. Thanks, Bradley.
Okay. Thank you very much, everybody. Bye bye.